Everyone, my name is Matt, and thank you for joining for my talk called I Have an Access Token, Now What? So the obligatory Who Am I page. So my name is Matt. I work at Morgan Stanley in the security design team. I was previously the API platform tech lead. I've got a master's that primarily focuses on security, and I am a co-author of Mastering API Architecture with James Goff and Daniel Bryant, and that's our book. Cool. So what are we going to be? This is a quick agenda. So why give this talk? What is an access token? How do you introspect them, and where you should introspect them within your architecture? So that's what we're going to be covering today. So before we start getting into the topic, there's an assumption that you're already kind of familiar a little bit with OAuth2, but I'm just going to give a quick refresher of the roles. So we have a resource owner, and a resource owner grants access to their resources. An authorization server issues access tokens to the client, and the client is an application. And the authorization server would ask the resource owner if they'd like to grant access to that client, so that application. So the client application wants to access resources on my behalf, for example, or the resource owner's behalf. And the resource server protects the resources. And if a valid access token is presented to the resource server, it would respond to that request. So just to give a concrete example, a system holds data about conferences. So a system holds data about the conferences, and I've been asked by the client, can that client access my information about those conferences from the resource server? So the application would forward me over to the authorization server, and I would authorize to say, yes, this client can access these resources on my behalf. It would issue an access token to the client and send it over, and then the client would use that access token to send it to the resource server, and the resource server would determine whether it's going to serve that request or not. Okay, cool. So this is the part that we're going to be concentrating on within this talk: the access token being sent to the resource server, and whether the resource server should serve that response based upon the access token. Cool. So this is that part exploded into a bit of a C4. We see the authorization server, the resource server, and the client, and we can see the bottom part, the request from the client to the resource server. And this is a bit of a more concrete example based on that, what I was talking about before. We've got Keycloak as the authorization server, and we've got a conference system, which is the resource server. Cool. So why give this talk? OAuth2 has been around for... So why give this talk? OAuth2 has been around for over 10 years. So do we even need this talk? The issue is I still get asked the question, I have an access token, now what should I do with it? And it's not that someone doesn't understand OAuth2 as a concept. They can use the libraries to get hold of an access token, and there's frameworks that are available that will do the authorization checks of access tokens. But people have more specific questions, such as, where do I terminate the access token within my environment? How do I even know if the token is valid? The makeup of the access token, what should I be looking specifically for in it? And I need to customize my access token because there's some information that's missing. So should I change the values in there or not? Depending on the authorization server that you have, that may be a possibility. So the concern is that we have this access token, which is a credential, and the resource server will make the decision whether it should give access to those protected resources or not. And so we need to determine if this credential is valid or not. So we're taking a look at our architecture, and we can see the conference system is actually built up of two different things. It's got an API gateway and the conference service. And this conference service is the implementing API. So this is very typical that you'd have an API gateway fronting your API, because the API gateway provides additional security by doing things like rate limiting, input validation. This is where you do your auth checks and, for example, audit logs. So what we're really looking to focus on here is coarse-grained authorization And by that, what do I mean? So coarse grained authorization is where we want to stop requests reaching our the underlying API, the implementing API, if the request is not valid, or in this case, if the access token is invalid. And by this, I mean, is the client, so the client, the mobile app in this case that's making the request, has it got permission to even call that conference service, that API? Has it been given permission to access that? Is the access token intended for that API? There could be an alternative system that exists within the conference system, such as the CFP service, call for papers service, and the access token is intended for the CFP and not the conference service. So where should this access token, should it even be able to send it to this correct service? And then, is the access token even valid in the first place? So that's what I mean by coarse-grained check. Fine-grained authorization checks, I would say, were things that are based upon a user. So very specific, low-level checks about what an individual user is allowed to do, as opposed to a client as a whole. Cool. So this is where we would be performing our coarse-grained checks. And this is where we're going to focus on really in this talk. So to see if an access token is valid, we need to know what is the access token. So an access token defined in OAuth2 is an access token is a credential used to access protected resources. An access token is a string representing an authorization issued to the client. So it's quite opaque in the sense that, you know, it just says effectively it's a string. And this is fine. And this was created at the time when there was lots of different companies that wanted to adhere to OAuth2 protocol, but their credentials that they used were different. And having something that's very opaque and not being specific about this is what an access token should look like can increase adoption. Because if, for example, Azure, they have tokens that they use in one format, or Google, Keycode, or Auth2, they can all adhere to the OAuth2 specification, yet their access tokens look different. And that's fine. But it does mean that we have no single design of how an OAuth2 token should look, and there's no specific specification on exactly how to use an access token. So therefore, if you're building your resource server, which in our case is going to be this conference service, it means that if you're using multiple authorization servers, you need to understand how each one of them issues access tokens so you can handle them appropriately. So access tokens have basically boiled down to two formats: JOTs and opaque tokens. So JOTs are the most popular as an access token format. So there is a specification for JOTs, and within that specification, it defines how a JOT should look, and which consists of a header and a body, and it can either then be signed or encrypted. So JOTs are simple and easy to process, and they are compact, and I think even says in the spec that they are good for this type of situation where you want to use them as part of requests. With JOTs, with a signed JOT, we're going to have a quick look at an example here. So you can see here that a signed JOT consists of a header and a body, which is the blue part, and we can see what that is, what that looks like. And all it is it's just big 64. So we've got the left-hand side, the blue part is the encoding, and the right side is the decoded base 64 value. And we can see this is all in clear text. So to validate a signed JOT, what does that require? It means that if you want to validate a signed JOT, you require the public key. And this is typically hosted by the authorization server, the well-known endpoint. I'm sure you're all familiar with that. But when you've got the public key, you can look at the signed JOT, and you can say, if you take the header and if you take the body, you can validate if the signature for it is correct, because the authorization server would sign the header and the body with the private key. So, and that makes it really easy to check checker jot in place. You don't have to go anywhere. You can just do this in a single place. But a bit of a downside to that is if the client wants to look at the access token, and it can decode those values and it can see what they are. So if you decided, well, we need to insert, for example, some PII, or we needed to have some other data that we wanted to hide from a client, you would look at using something like, look at using encrypted jots. However, you've then got to then encrypt the jot, but then also when you're wanting to validate this jot, you've then got to decrypt it. And that means that you've got to have key management. So if you're using asymmetric keys, then the authorization server would have to encrypt it, and then you'd have to have the same key available for the resource server as well, so that it can decrypt it in place. Again, jots are still really valuable because you can just do this in place. You don't have to go anywhere or send the token anywhere else so that you can decrypt it, or you can validate it. All can be done in a single location. Cool. So the other version of access tokens is opaque tokens, and these are just long random values. And I've just taken an example one by Cloud Density. And as you can see, this is just a string, and there's no identifiable information within the token. It must be looked up. So that means when a resource server gets the access token in the opaque token format, then it has to go and look it up from somewhere. Cool. So we're going to come more onto opaque tokens and looking them up in a second. But what we can see here from our diagram is that we now know the access token formats that are going to exist and that are going to take place. So see that here. So depending on your organization, you may have control over your authorization server and the access tokens that format is going to be issued. There is obviously pros and cons to each one, as we've covered. So it's a good idea to ADR this up, make this an ADR, and say which access token that you as an organization are going to use. Cool. Right, so now we're going to talk about introspecting those access tokens. So with when you're looking at an access token, as we said, you can validate jots in place, so you don't have to send them off everywhere. While opaque tokens, you would need to send them off to the authorization server to get back information about that. And there is a specification on how that can be done, and it's called the token introspection endpoint. And I really like the idea of having a token introspection endpoint. Not all authorization servers support them, but the ones that do, I think it's a really good implementation. And the reason being is that the information that you get back from the authorization server is the same information, what's in the spec, same information that you would typically see within a jot, like the same style of claims. And this can be really powerful, because it doesn't matter if you have an access token which is actually a jot, or if it's an opaque token, you can send it to the authorization server and you'll get back a consistent set of claims. Cool. So the benefit of that is that, like I said, you get these consistent claims. So it doesn't really matter whether you're using a jot or you're using an opaque token. They are consistent. So we can kind of think about it from now on is whichever token format you've got, you're still going to be looking at the same claims and values in either way. Cool. So you can see that here. So if you had an API gateway and you were going to look up your access token, this is where it would be done. So your API gateway would make a call to your authorization server to inspect the token and get that back. And we're going to be able to see that here in our demo. So this is just a small little demo. This is a small little demo where we have an access token. So the access token is created. I've just done this with the client credentials grant, just with a local keycloak instance, just because it's very easy to get set up and running. Cool. And then once we've got this access token, we're then sending it over to our keycloak, the authorization server, and we're sending it to the token introspection endpoint, and we're just pumping that out to JQ so we can see the response. And you can see these values here look very much the same as the ones that we would see in our job. We see the audience, the sub, we see the expiration. These are all values that we'd see typically within a job. And there's a very useful claim as well called active. Okay, so I'm just going to extract that individually using JTQ. And in our case, we see that the active value is true. And this is a mandatory value in the token introspection endpoint. And it tells you if this access token is valid or not. So the authorization server can handle a lot of the introspection for you. So it can ensure that it's for example, within a job, you've got claims about the time, like is this token expired or not? When was it issued? And based on those values, it can say, well, the token, the time has gone past, so therefore it's not valid. So it can make those decisions, and depending on the policy that is implemented, it can handle the introspection for you. So we can see that here. Well, with this access token is only valid for 30 seconds, so we can check it again, and we can see the only value that we get back is false. So therefore, this token we know is now not valid anymore. Cool. And this, in our case, you can see here, this was using a JOT as an access token, but also because Keycloak don't do opaque tokens. But if it was an opaque token, the response would be the same. Cool. All right. So we've got that's that. Awesome. Right. So we'll have a look at that next part. Right. So the next part is of the bits of information we want to check at the edge of our architecture is some additional claims. And again, these would all be claims that you would expect to find within a job or from the response from your introspection endpoint. And these are the scope, the audience, and the something like the ACR. So the scope. So the scope claim is what the client application is authorized to access. And this is not to do with the user, it's very much to do with what the client application is authorized to access. So imagine that we've got two endpoints here. We've got a get endpoint for conferences and a post endpoint for conferences. Now, when the resource owner is asked to authorize, like is asked to authorize whether the client, so this mobile app in our case, can, for example, read conferences or write information to the conferences endpoint. It's about what the client can do. So in my case, I would give permission to say, yep, this client application can read this information on my behalf, but it can't write, for example. So the scope claims it would contain would be the conference read. So if the client sent this access token to the conference endpoint on the get request, it would say, yep, that's fine, the scope value is good. But if it sent it to the conference endpoint to the post conference endpoint, it would then reject that request because it would say, well, you don't have conference right. You as the application haven't been given that permission. And again, the audience value is another claim where it's about where this token is intended to be used. So, for example, let's just say we've got this domain api.conferences.com, and then there is another domain subdomain called forums.conferences.com. If the access token was actually intended to be used at the forums.conferences.com, and it was sent to the different, and that endpoint was called, what we would find is that request would be rejected because it's not intended for that endpoint. And the last one is the ACR. And I think this is really useful if you've got APIs where you require information about how someone has authenticated, how the resource owner has authenticated, or how, depending on the machine to machine, using the client credentials grant, how they've authenticated as well. And this is if you've got some APIs which you want to have very secure. So with the ACR, you can see in the get conference endpoint, we said ACR1. And by that, it's a number value, but 1 would represent, for example, a password, and 2 would represent MFA. So we may say, well, if you can call the conference's endpoint and you're using ACR, you've got ACR1, you've just used a password, that's fine. But if you wanted to create a new conference, let's just say if you were organizing API days and you wanted to create a new conference in API Days Japan 2025, well, we want to be very sure about who you are. So therefore, that person may need to use a higher level of authentication to be very sure about who they are. And there's a specification all about step-up authentication in OAuth2. Cool. And again, if you didn't have that, you would then reject that at the edge. So that's covered introspecting APIs. But where do you do this now within your architecture? Cool. So we've talked about, we want to do that at the edge. And you can embed all your policies within an API gateway, but I think a really nice idea is to try and put this in a PDP, something like OPA, and take the policies that you want to implement about access token introspection within a PDP. It means if you change your API gateway implementation, then you've still got a centralized point of how to introspect your endpoint. And also the policy in these PDPs, the policies are usually written in kind of quite a readable format. So it makes it easier to read rather than making something very bespoke per gateway type. And then once you forward this, you can then forward your access token down to the implementing API. And this is where you'd still want to revalidate that access token again. But you would then do your fine-grained auth checks within the API about what an individual user may be able to do based on either an ABAC model or RBAC model for that individual person. Cool. All right. So thank you very much for listening. I hope that you found this interesting. Any questions?